Damian is somebody I know for many years. He is, as far as I'm aware, he is Ireland's original game developer. I don't think there's anybody I know uh, significantly before Damien as regards a professional game developer. And, we're probably all here because of his pioneering work in the early days of 8-bit and 16-bit game development. Back then there was no Unity, there was no Photoshop, there was no visual scripting editors. You had to do everything yourself. And, so a real pioneer in the early days of gaming. So I'm going to hand over to Damian, and he's going to tell us a bit about his story.
Everybody here today, we're a combination of musicians, writers, game designers, and coders, and lots of different artists, as I would describe us. And it's our job to create, inspire, and play every day. And that's what I expect us to do today at the conference. So let's go for it, right? So this is the story of a young guy on the left. Started off in Baldoyle in Dublin 13, working on games in his back bedroom, who over a number of years in the 80s became one of the largest game developers in the country and worked on the world's largest games license, the Moonwalker video game license. So what I want to inspire everybody today is in terms of how did that happen? How did one young guy start here and finish working on such an amazing game, right? So let's start. This is the story of how I am that game developer, and I'm probably the most famous game developer you've never heard of. In fact, in the 80s, I developed lots and lots of games, so many actually that I've actually lost count of how many games I developed. At the time, I just turned out lots of different games, and I worked for lots of different people. But it was a very exciting time. So let's refresh. We do a reboot back to 1981. And this is my very first computer. It was a ZX81, which had 16K of memory, and it was a Z80 chip. So as Peter said, it was very slow. There were no dev tools. So if you wanted to do something, you had to work out how to do it yourself. And I learned as I coded. And it took me a year or two to learn the basics of machine code programming and basic programming on this machine. Now, I want to sort of put a perspective to sort of just for the technical people out there. So you might find this amusing, right? The ZX81 at the time, this is Moore's law, the number of transistors and microchips. At the time, the Zilog Z80, which is my chip of choice, had about 8,000 transistors in the chip. So that's about the max processing power you could put into anything at the time. The iPhones of today are up here, have in the region of 10 trillion transistors. And the latest chips that are coming out now are looking at 50 trillion transistors, right? So just to sort of put that in perspective, that's a huge difference in processing power. Okay, so that's all techie stuff, but can you say that to me in English, Damien, right? So here's an advertisement. I tried to find something useful for us. In 1981, there was an ad came out for a fast loader, which would load and save 16K in only 29 seconds. Amazing. Now, I showed this ad to my 18-year-old son the other day, and the first thing he said was, "So you had to wait how long for something to happen?" So that was a big shock for him, right? Now, this was the turbo loader. The normal loader was 3 minutes, right? But okay, does that mean anything? Okay. The average app today, if you look at an iPhone app, is about 32 megabytes in size. So that means by ZX81 standards, it would take 19 hours to load an app on my ZX81 if you could fit it in, right? So the reason why I'm showing this is that in terms of developers, we had to code really fast and really tight. So we had not a lot of memory, and everything had to be working really, really fast. So an iPhone app is about 2,000 times bigger than the machine memory on this machine, right? So on the bright side, once I learned how to program, in 1983, the ZX Spectrum came out, and this had a massive 48K of memory, so a bit more different. So you had a bit more memory and a bit more power, and that sort of started the ball rolling for me, right? So I got one of these, and I said, right, let's start writing games. So believe it or not, these are the first graphics that I ever drew. because I actually keep all of this stuff, right? In the old days, without tools, we used graph paper, good old-fashioned math paper that you all probably used in primary school, and you would draw the graphics, and you can see the little man, massive 2-frame animation here, living the dream, right? You would design your graphics, calculate the binary, type it into decimal, and then put it into your computer. So that was the game. So this was Insomnia, right? And I'm going to just show you a very quick demo of Insomnia, right? Just so you sort of get an idea. Just going to lower the volume because I don't want it too loud for you. So this is the music I wrote. And then it also has the game as well. So it was a very simple maze game, which involved running around a house, collecting clocks to stay awake. And if you didn't have enough clock energy, you fell asleep and died. So a very simple game. Now, the reason why I'm showing you this game, right, is because there's a couple of important aspects in it, right? So first of all, I had to write the music. I had to write the code. I had to design the graphics, and I had to design the maps and put everything together. So I developed a full package. I even had to develop a loader. I developed the cassette box. I did everything in this game, right? And why that is important is that it taught me how to develop. I had a platform to develop a complete game. Nowadays, you see lots of demos, but demos may be great, but can you actually develop a game? And that's really, really important, because from here, I had a base to work from. So I went out with this and started looking for a job. And the first job I came across was, believe it or not, Mentor Educational Services in Trim, County Meath. I have the names of the places here because it's interesting for people here maybe to see that there was little pieces of development going on in different areas around the country. So what Mentor developed educational software for children. Now, strange as it might be, it taught me maths because we were learning all about maths, and there was all math programs, and there were games. So that gave me math skills and game skills. And it was my first job. So my advice to you, if you get offered a job, guys, take your first job because it gets you into the system. I developed probably about 30 or 40 titles from Mentor, and it gave me huge experience in terms of how to write product. Which then, as I started to look for my next job, I came across New Concept, which is actually Ireland's first games company. And they developed a surfing simulation game. So it was, you basically surfed on the computer, right? Now, talk about that in a second. But they were looking for people that had maths and had games experience, and that was me, right? And if you want to know more about this game, the BBC recently did a review on it on the sports section on their website, and Retro Gamer magazine also did a review of it. And this is Norman Macmillan, the CEO. So certainly he was the original inventor at the time. Lesson from this is to take opportunities. When I was originally hired in New Concept, I was hired as a Z80 programmer. But the day I arrived, they said, we've decided to develop the game on the Commodore 64, and you're the 6502 programmer. So I had to learn 6502 within about a week, which I did, right? And I also sort of cheated because I wrote some macro code that allowed me to write Z80 that would recompile into 6502. So a bit of a cheat, but I'm probably the only Commodore 64 programmer that wrote in Z80, right? So that's New Concept. And it was a great game. It was the world's first surfing simulator. It was a real simulator. It had a little plastic keyboard. So rather than having, up, down, left, and right, it used a number of the keys. And the plastic surfboard, as you press down, so you press on the front if you wanted to do an air or something like that, it would, or a hang 10. It would probably press 2 or 3 of the keys, and based on that was able to use sort of pressure to identify which keys you were pressing, which side of the board you were pressing, and then would react accordingly. So really amazing game, and they had lots of great ideas. But sadly, in the 80s, funding was not really available, and they eventually ran out of cash. But this was a very successful game. So I started looking for more jobs, and then obviously because of the reputation that Ireland had for games, Emerald Software then came over from the UK and set up over here as Emerald. So these were Ireland's first big developer, and it was formed by Mike Dixon, who's ex-EMI in the UK, and Dave Martin from Martech. Was a great company. Over its lifetime, it had about 17 programmers and 5 graphic artists, and we did a whole slew of games. A lot of them are sort of good games, right? So we did everything from Michael Jackson's game to The Running Man for Arnold Schwarzenegger, but more of that later. All right. So that was Emerald. So my big game here was Vigilante, which I wrote, and it was a huge success. So it was a massive amount of effort that we put into developing this game. I got front cover on yours and Claire. This is the ad on the right, and it was all over the place. It was a really great instant. Now it took us a while to do this, and I'll talk about it as in the presentation. So here's the challenge for Vigilante. This is the arcade game on the right, and we were asked to convert this. So an arcade game has lots of RAM and memory and sound chips, and it can do lots of stuff. So how do you squeeze that into a 48K Spectrum? So the first thing I did, big step one, was I needed to develop a graphics engine. So because I knew once I had a solid graphic engine and I could blast sprites out as fast as physically possible, I was in business. I had something to work from. So that's what I tried to do. So believe it or not, on the right-hand side, this is the original code. I do have the original code for all of my games, so it's quite interesting to see. The engine was developed to display probably between 48 and 64 sprites simultaneously, right? So that was quite a challenge at the time, because to be able to get the maximum speed out of the machine and to get constant speed, if you can see on the right, there's a list of sprite routines. We didn't have a single sprite routine. What I developed was I developed a sprite routine to blast someone in the center of the screen with no color, sprite routine to blast something with color, something to clip on the right, clip on the bottom, and clip on the left. So there are multiple routines, all straight lined, to make them as fast as physically possible. Now, interesting, again, to put this in perspective to today, at that speed, running that amount of sprites, there literally was smoke coming out of the back of the Spectrum, right? Recent tests on GameMaker Pro, or the system, there was a test they did last year on YouTube, and they had 32,000 sprites per second running on the machine on a PC with no slowdown whatsoever. So that just shows you how hard it was for us to make things move. So this is the game screen, and I just sort of give you a sort of a perspective of it. If you look, you can see the blocks. There are 8 blocks by 5, so that's 40 sprites, right? So the background was built up of 40 blocks, and each of these blocks could be scrolled, moved left and right, right? You also had the main character that was 2 blocks, and then some of the bad guys were either 2 blocks, 3 blocks, or 4 blocks, depending on the size of the character, right? And then the yellow section here, the dotted line I outlined for you, is a background sprite that was used for parallax, and you'll see that in the background. So that gave the game a little bit of depth. So I wanted to show you that, so at least you sort of see the thinking in our design. We spent a lot of time designing the structure of the screen before we did anything. So this is the game now, and the famous just going to man with the shooting man. So watch out for this shooting man, because I'll talk about him later. So I'll give you the idea of how the game worked. You can see the parallax scrolling with twin towers in the background, which sort of dates the game. And it was basically you went around, you beat guys up, and you became a vigilante and saved the girl at the end of the game. But it was a great game. It was a good game to play, and was one of my, as a very successful at the time. Got to, I think, number 3 in the charts in the UK. So really cool. So that's Vigilante, right? So we'll move on a bit, right? So I talked earlier about how the graphics on the arcade machines were huge. So how do you get graphics into a very small machine? So we spent a lot of time as developers, and I spent a lot of time trying to work out how to do this. So first of all, you looked at, here are 2 bad guys. So we would store all the graphics facing to the right only, and we would use a flag to tell us which way someone was facing. And then I would have code that would flip the graphic in memory before I displayed it. So that saves 50% of your graphic space. You would also share parts. So these trousers, if you notice, they are wearing the same trousers. Saves another 25% on space, right? And then there are things like nunchucks and weapons like that, and they were actually added on top. So it's not like we didn't store the full body with the weapon. We stored the weapon and we just stuck it on top. So it wasn't absolutely perfect, but it was great because you were able to get it in, and that saved another X percentage. So we used every trick in the book to try and save space. Now, that was great because it saved lots of space, and you can see it looks really cool here on the full screen. But you can see the guys wearing the same trousers, right? Another running topic through my presentation. The downside of doing this is that occasionally, as you can see in this graphic, the trousers just, just wasn't perfect because we just didn't draw it perfectly right. So it just wasn't great. But one of the things that you can take away from any game is that when characters are moving at speed, nobody notices a couple of pixels here and there that are out of place, or certainly at the time they didn't, right? But it did allow us to cram huge amounts of data into such a small machine. The next part, and this is probably useful for Peter because I had a conversation with him about this the other day, is right. We actually had project management, believe it or not. It wasn't just me doing my little thing. I'm one of those sort of mathematical based guys, and I used to use probability analysis to calculate when I was going to ship something. So this is my weekly project sheet that I had to develop for US Gold, and I delivered it to them every week to tell them how we were doing. So I'll drill into some individual pieces on it. So Vigilante on the Spectrum took 115 days to develop, and I was 10 days late. So that's not bad when you think. So about 4 months to develop a game. Be interesting to see. I know what everyone's perspective is today about whether that's a long time or a short time. But it was a long time for us, right? So that's how long it took me to develop it. So why was I 10 days late? So here are the interesting. Let's look at some of these problems. So first problem, number one and number two. Well, number one is first, right? Is that I actually ran out of space. So there's no memory, and I couldn't put in the loader. So there was no tape loader, means I couldn't ship the product, right? So the only way to fix that was I reduced the walk frames on the bad guys. So from 4 torso frames to 2. So they just didn't wave their arms as much when they walked, right? And I did a few other things. But it gave me, if you look carefully, 239 bytes now free, I said, right? Amazing, right? The other part then was I was pulled across on the Running Man, which is point number 2. So the team that developed Running Man needed assistance. At the time, I was sort of the expert on the Spectrum. So they needed help developing sound routines and the tape loader system, because obviously I was good on the tape loader system because that was my specialty, right? So there's actually a small piece in the Running Man, I think, where Arnold says, as he goes down a tunnel, he says something like, it's showtime, and on the Spectrum. And at the time, to have any speech on the Spectrum was amazing. So I did that, right? That was that, right? And then I had to make some changes for US Gold. So what were those changes I had to make for US Gold? So we go down to the bottom, and you'll see to save space, I dropped some of the van. There was a van that moved, so we stopped the van moving, and we dropped the gunman. Oh, but would you believe US Gold come back and said we put the gunman back because he's part of the game and we wanted him, so we had to recode that back in. So that was sort of some of the reasons why I was late. So it generated an extra 2 weeks work for me. So hopefully that gives you a sort of an idea of how to develop a really cool game, what you require. So from that, on the success of that, we were approached then by US Gold to say, look, we've got this really cool game, Moonwalker. So you guys can obviously deliver. Let's go for this. So we were offered the contract for this, and I was given the challenge of developing the Spectrum and the Amstrad version of the game. So this was an interesting, it was quite a complex game because it was based on a film. So we were restricted in the ideas that we were able to do. This is some of the original artwork. It was developed by Ger O'Carroll, who was an ex-Sullivan Bluth designer. So he was able to do some really, really cool artwork for us. Now, trying to get into a Spectrum is a bit of a challenge, but we did our best and we got a lot of it in. Just the loading screen of the Spectrum. So I'll just show you a couple of bits, right? But before I do that, I wanted to show you something that doing a license like Moonwalker is a challenge because the quality out of what's expected. Like at the time, Michael Jackson was the largest, person on the planet, right, in terms of fame, right? So in the beta version of the game, we had the image on the left, and this is the image we had of Jackson. But I was very quickly pointed out to me by US Gold. They sent me this image that Michael Jackson stands on his toes. So please fix all the graphics. So we had to go back to our designers and do quite a number of graphics to make sure that it worked correctly. But it sort of gives you the focus that even then, attention to detail for every game was so important. So this is Club 30, the background of Club 30, which is a sort of a shoot 'em up game. The challenge with Moonwalker was that it was actually 4 games. So the first 2 levels were a sort of a car chasing game, and then there was the Club 30 level and the next level, which I'll show you. So this is Club 30, which is I'm going to just check the volume again, and I'll give you an idea. So It was a scrolling shoot 'em up where Jackson ran around collecting bullets, collecting machine guns, and shooting at the different bad guys in the windows. Another challenge, as you could hear, is the music in the background. Each level had a different piece of music uh, from the album, and I actually remember, just from quality point of view, one of the team from US Gold actually came over and sat down beside me with a stopwatch and timed the music to make sure it was playing at the correct speeds. So that was a challenge in its own right. Then the final level was Michael Jackson would come in as a turn into a transformer, shoot lots of bad guys, and save the world, right? So original artwork, and then I've sort of compressed this, so it's not the whole level, but you get the idea. So the challenge here was the size of the graphics that we had to use. It's a pretty big animation, and that you'll see in a second. There's a huge laser cannon comes in, and it's quite so to get that animated on a spectrum it was quite difficult. And then the final scene when he changes into a transformer was also a challenge. So that gives you an idea of the game and how it worked, right? The last level was actually the most difficult, believe it or not, because just the size of the graphics takes up a lot of space in the spectrum, so it was hard for us to do. So that was Moonwalker, right? It was a fantastic success. Again, another top five game, right? Was all over the place. Every magazine covered us, and we got a lot of fame and coverage from this, right? And that was sort of the pinnacle of my career. After this, Emerald tried to do a few other games, and we tried to push stuff, but again, from lack of funding and stuff like that, the company eventually sort of folded and moved back some of the game stuff into the UK, right? So that was Moonwalker. So what happened after Moonwalker then was I sort of took my leave, and I went freelance, did a whole lot of different things. I went to work for a company in the UK, and we developed Super Ted, which also was a number 3 hit in the UK. This is quite interesting one for me because, believe it or not, Super Ted is a Cosgrove Hall production. It's from a cartoon series, children's cartoon series, and they are looking at re-releasing it again in the next year or so, which would be great to sort of see again. And I also developed some other games on the Spectrum, like Blam, and then I created my own company for a while, and I did games on the Amiga and the PC and things like that as well. So lots of different things going on, right? So that's my side of the big story. But I wanted to share one particular game, which is just briefly towards the end of my presentation here, that I thought might be just amusing for you, right? So how to be famous, right? So I had got a lot of fame and love from doing lots of different games, but I was thinking, how could I get Damian on the front cover of a magazine? Now that'd be interesting, wouldn't it? So what I decided to do, I wrote a game called YS Capers. So here's what I did, right? Your Sinclair magazine had huge coverage. So what I did was I took the 4 lead reviewers and authors of that magazine, and I digitized their images, turned them into graphics, and made a game about them. So when I went to the magazine, I said, "Oh, I have a game, by the way, and all you guys are in it. Would you like to buy it off me?" The answer was yes. So it's a very simple way to get some good PR. And they put me on the front cover of the magazine, and they did a little write-up on me and everything. So it was great for me to do, right? And I'll just show you very quickly the game. So this was a quite actually not a bad game, based on Operation Wolf. And basically, you play. It was a 4 or 5 level game where you shot all the different the authors. Right now, interesting for those who are paying attention to my presentation, you may notice that the 2 guys that run from left to right share the same legs, so they're sharing the same trousers. I wonder where I learned that trick before, right? So that's another one for you to sort of see how we did things, right? And that was really cool game, right? So so finally, I wanted to bring us back to today, right? And just games I admire, just sort of share with you. So this is where we were in the 80s, but why do I like stuff today? So my favorite game at the moment is Little Nightmares, all the versions. My daughter plays it all, Emma plays it all of the time, right? Because I think the storytelling in it is absolutely phenomenal. It's a very simple game, but not taking away from anything. It's a simple game told phenomenally well, right? I do like Hollow Knight, and I know that can be a controversial game. Some people think it's depressing, some people think it's great, but the graphic style is very unusual, and they're making the most of what they have, right? And then finally, Red Dead Redemption. Oh, again, all versions of it. This pushes the game to its limits. If you go back to what I was talking about, I had my Spectrum and my Spectrum engine, and I pushed it till smoke came out at the end of the machine. I think Red Dead Redemption does that, and I see that all the time. And I do ask questions. What about the game engines there today? How, if you look at them, how far could you push them? Where are their boundaries? Can Unity be pushed? Where can you really make it shine? And that's something you should sort of take away from today, right? And so think about those things, because there are different ways to tell stories, right? So here's the lessons that I want you to walk away with from today. So one is document your work. So you can see I have the images and I have lots of stuff, and it's great to look back at stuff and learn from my mistakes, learn from my successes, and carry that forward to where I'm going. Push your limits all the time. If an opportunity arises for you, take it. It doesn't matter what it is. Get into the business, get going, and try stuff, right? It doesn't matter how good it is, how bad it is. Get into business and get moving, right? And have some fun, and keep your ideas, right? So here's an example. So Scattergood Studios is my new sort of games company, and I'm looking for ideas. So where do I get my ideas from? He says. Okay, so I went to my attic and I found this massive box which has loads of ideas, because I documented it. So these are all games, the concepts, and I have the some of the code, some of the graphic style, some of the story, and those who are very observant will look up there. You see a game called Ninja Chicken, which I thought was hilarious, right? But you never know. One of these days, you may see it on a platform near you, right? Because I have this spec. So on that point, let's go create, inspire, and play more games. Thanks, everybody.
Brilliant. Ninja Chicken, I like it, Damian. Really interesting. And for people who may not be aware, just Damian's work and the breadth of work, that the games industry, people think, with the studios here, but it did start in the 80s, 90s, and and working on major IP titles. So really interesting stuff, and also interesting that the design, memory had such a big issue on design implications. Actually, Damian, we do have a question from the audience. So Kieran Nolan asked, and we've just time for one question. Okay. Were you given any source materials from the original arcade developers? And that question's from Kieran Nolan.
No, we weren't. So the only thing we were given on the arcade was a board. We had an arcade machine in the office that had a button instead of a coin slot. So we would go in the mornings. This actually is a good question, actually. So part of our job was to play games. So we would go in the morning and rack up 500 credits on the machine and just play it. We would take notes. We would take photographs with our very old-fashioned normal cameras, and that's how we got the spec for the game. And there was nothing we could do. We could open up the machine, look at the ROMs, but it was done the hard way. Play the game. If you couldn't play the game from start to finish, you couldn't write it. Does that answer the question?
Damian, listen, thanks a million for that really interesting, inspiring talk as well. And again, if you want to reach out to Damian, you have his details there. So thanks a million, Damian.
Yeah, brilliant. And feel free to contact me. You can ask me anything later on.
Cool. Brilliant. Thank you very much.
Thank you, everybody. Thanks.